All right, so another application of antiderivatives and integration is kinematics, where we're talking about position, displacement, velocity, and acceleration. So I could easily give you an acceleration function and ask you to figure out what the velocity is and what the position is, what the displacement is, what the total distance traveled is. So I could ask you all of that, and to do all of that you would need to do integration. So I have a particle moving along the x-axis. I've given you the acceleration function 6t minus 14, but I've also given you some other information that's going to help along the way. Remember, when we integrate, we have these constants c that show up, and anytime I have some information that helps me find that value of c, that's actually very helpful. So I know that at t equals 1 the velocity is -1 and the position is 4. So I need to know what is the position at t equals 4. So I start off with my acceleration function that I was given, 6t minus 14. To get to velocity, remember acceleration is the velocity, or is the derivative of velocity, so velocity is the antiderivative of acceleration. Whew. That was a lot of words. So I'm going to take the antiderivative of this, and I'm going to get that velocity is 3t squared minus 14t plus some constant. And I am going to run across two constants while I'm doing this, so I'm going to call the first one c1. All right, I do know that when time is at 1, then the velocity is -1. So what I did was I took my velocity function, replaced all of my t's with 1s, and set it equal to -1. So I've got 3 minus 14 plus c1 equals -1. So what that means is my first constant is 10. So I now know that my velocity function, more specifically, is 3t squared minus 14t plus 1. So now all that's left is to take the antiderivative one more time to get to position. So I have my velocity function that I just figured out, and my position function, my x function, is going to be the antiderivative of that, which is t cubed minus 7t squared plus 10t plus another constant that I have to figure out. And to do that, remember, I was told that at time 1 the position was 4. So in my x function I replace all of my t's with 1s, and I set the whole thing equal to 4. And that leads me to a value of ct equals 0. c2 equals 0, so that, more specifically, my x function is t cubed minus 7t squared plus 10t, and my constant at the end is 0. So that is the complete function. So to answer the question, where is this particle moving along the x-axis when time is 4? So since this is the complete position function, I simply need to plug in 4 as a time and evaluate, and that gets me that the position will be at -8. So the particle will be at -8 on the x-axis at time equals 4. So that's just one example. We're going to go through more tomorrow. If you have any questions, let me know, and I'll see you tomorrow.